Hi to all the Form 4 students. Today I will teach you a new topic which is very useful in our daily life. As you see just now, the MAS, our Malaysia National Airlines. So this topic is something related to airline, which is vectors. Okay, our learning standard is today we want to compare and contrast between vector and scalar, okay, and hence identify whether a quantity is a vector or a scalar by providing justification. So you have to actually understand the meaning of vector quantity or scalar quantity. Alright, so and then maybe you have to know how to represent vectors by using directed line segments and vector notation, and hence determine the magnitude and direction of vectors. Okay, followed by make and verify conjecture about the properties of scalar multiplication on vectors, and finally make and verify conjecture about parallel vectors. So these are 4 important learning standards for today's lesson. Alright, so make sure you really understand the topic before we proceed to the next subtopic. Alright, okay, so please follow me for the next lesson. So now I need to brief you about the significance of the vectors. We often hear and learn about quantities such as temperature, force, length, acceleration, translation, and so on. There is a difference between these quantities, whereby some of the quantities only show values or magnitudes, while some of it show both magnitude and direction. Scalar quantities such as length, temperature, and so on are always associated with numbers, which are the value of the quantity, while vector quantities such as force, acceleration, friction, and so on have magnitude and direction. So vector is quantity that has a value, which is magnitude, and direction. So we may not realize that we often apply vectors in our daily life. Many studies have been conducted to find the application of vectors in daily life. Vectors in navigation. In navigation, such as in the field of sailing and astronomy, vectors have a significant role in the existence of location in terms of a moving place, such as a vehicle and so on. This technology is called Global Position System, or GPS. The system tells us the location on Earth even if the place is moving. Thus, the vehicle can know its location and its destination. It is found that vectors play an important role in navigation. For example, vectors are used for aircraft navigation systems. Vectors in computer science. In the field of computer science, vectors are used in imaging. Graphics are images that are made up of coordinates. Therefore, the source of image that appears on the computer screen consists of points with a value of coordinates. The monitor screen acts as the x and y axis. Vector graphics are images formed by the combination of points and lines using certain mathematical formulae. Examples of software that use vector are CorelDRAW and Adobe Illustrator. In computer software such as AutoCAD, Google Sketch, and others. There is a computerized vector calculation. This program functions as a three-dimension building design, drawing before constructing a real building. In this program, there are three axes: x-axis, y-axis, and z-axis. So this is a three-dimensional axis. Let's see vectors in geometry. In geometry, the coordinate system is a system that uses one or more number of coordinates to determine the position of a point or geometry element. The order of the coordinates is important and sometimes identified by its position in a tuple as the x-coordinates. In mathematics, the basic coordinates is considered a real number, but in the advanced application coordinates can be noted for the number or complex elements of a larger system, such as the commutative ring. Use of the coordinate system allows problems in geometry to be translated into problems related in our daily life. Now let's see vectors in topology. Topology is a mathematical subfield related to the uniformity of the structure of space in the deformation of bicontinuous, from which is a space that can be bent, fold, shrunk, stretched, and twist, but not allowed to be trimmed, torn, penetrate, or attached. In its application for physics, topology vector space, or also known as linear topology space, is one of the basic structures studied in functional analysis. As its name suggests, space combines topology structure with the concept of vector space algebra. The element of vector topology space usually functions as a linear operator working on topology vector space. And topology is often defined to obtain certain ideas from the convergence of function sequence. For example, it can be used in computer network topology to calculate the long-range vector routing protocol. Hello guys, today we want to start with chapter 8, vectors. What will we learn? As usual, vectors, addition and subtraction of vectors. Okay, let's go through the important keywords. Vector, okay, is the important keywords. Magnitude, followed by direction, okay, and then you have to know what is directed line segment, which is a line with the arrow, zero vector, negative vector, and then collinear, and then resultant vector, position vector, triangle law, parallelogram law. Okay, all these are very important, and polygon law. All right, now this is our national airlines. This is a GPS system. And then we will start the vectors by comparing the differences and identifying vectors, quantity, and scalar quantity. In our daily life, there are various quantities with magnitude and direction, and quantities with magnitude but without direction. A quantity that has magnitude and direction is called vector quantity, while a quantity with magnitude but no direction is called a scalar quantity. Observe the following situation carefully. So, after you observe, please tell me whether it is a vector quantity or a scalar quantity. Alright? Let's go through the diagram together now. Okay, you have a refrigerator and the temperature of a liquid. There's a bottle of liquid. The temperature of the liquid is negative 12 degrees Celsius. So is this a vector or scalar quantity? Please tell me. A moving car on the road is heading to the south with a speed of 80 km per hour. So can you determine whether they are vector quantity or scalar quantity? Okay, now, so let's see. Example of vector quantity are 50 Newton of force applied to a box of velocity of a car 90 km per hour heading to a certain direction. Scalar quantity example, Auni's height is 1.48 meter, or the area of the tile is 120 centimeter square. Without scalar and vector, example are pressure and tension, okay, or the conductivity of matter. All these are without vector and without scalar. So, okay, so can you differentiate between distance and displacement, speed and velocity, and also mass and weight? So the following table shows the differences between those quantities. Scalar quantity, example distance, is the total length of track that is passed by a moving object. Okay, so distance is a scalar quantity. For displacement, it is a vector quantity. The length of the shortest line segment between the starting point and the terminal point and involve the direction from a reference point. So let's see the example given. So for the total distance is actually 40 kilometer plus 30 kilometer. Okay, so the total distance is 70 kilometer. And then for the displacement is actually 50 kilometer. For the speed, rate of change of distance against time. For velocity, rate of change of displacement against time. So the value becomes negative if the object is moving in the opposite direction. Let's see the example. Hazid is moving from A to B with the same speed and velocity, which is 90 km per hour. After that, he turned back from point B to A with speed of 90 km per hour and velocity of negative 90 km per hour. So you should have a clearer picture what is the difference between speed and velocity. Now let's have a look at mass and weight. Mass is actually the amount of matter that an object contains. The value does not change according to the location. For weight, the pull of gravity on an object. So the value is not constant and depends on the gravitational force of the location. So the mass of an astronaut when he is on the moon is 120 kg with a weight of 200 Newton, while the mass of the astronaut is 120 kilogram and the weight is 1200 Newton when he is on Earth. Alright. Okay, now we will see the example 1. State whether each of the following quantities is a vector quantity or a scalar quantity. Justify your answer. So, number 1. Mikhail walks 1 kilometer from home to the grocery store. So, this is a scalar quantity because the quantity only consists of magnitude. A car is moving at a speed of 90 km per hour to the south. Vector quantity because the quantity and magnitude and also direction is heading to the south. Alright, then finally, the body temperature of Alicia is 38 degrees Celsius. This is a scalar quantity because the quantity only contains of magnitude. So, okay, for today's homework, you just do practice 8.1. State whether each of the following quantities is a scalar quantity or a vector quantity and justify your answer. Okay, please do from A, B, C, D to E, and you may check the answer given after the class. Okay, I hope you have a better understanding of what is vector quantity and what is scalar quantity. Okay, so I hope you enjoy learning vectors. Okay, with that, I will provide you the answer for the exercise. So I hope you will enjoy learning additional maths. So until here, bye. Have a nice day.